Now, do you see a 10 on my table?
Yeah.
For t, do you see a value for t that's 10?
For T, no.
No. There's no t value of 10, correct? So, how do you think we're going to be able to approximate the derivative when t is 10? Someone said it. Slope, correct? So we're going to find slope, right? Everybody knows how to find slope. Now, what two t values, because to find slope is like x2 and x1 and y2 and y1, right? What two t values do you think would be best to use to find the slope at 10? 8 and 12, correct? And that's it. So when they give you this problem, this number is typically going to be between two of the numbers up here, like smack dab in the middle. Doesn't necessarily have to, but the way they write the problem, it's always going to be like in the middle of two numbers. So I'm really just going to find the slope of those two numbers. So r prime of 10 is approximately negative 14 minus 10 over 12 minus 8. And so that's just negative 24 over 4, or negative 6. That's pretty much it. Fairly easy, correct? Now, sometimes, and I'm going to go to one of these problems, sometimes they're going to say, write the answer. When you do free response, and I'm going to look at one, and I'm not for sure exactly what it's saying. A lot of times on this, it's going to say, write the units of measurement, which would be whatever R represents, recipes, whatever R represents, per whatever T represents. You need to make sure you do that. So whatever they ask you to do on a free response, you want to make sure you do it, particularly when you know how to do so, because every little step is some points. Okay, let me look at an example like this. It's actually going to be a problem dealing with velocity and acceleration, which I didn't plan on going over with you until next week actually, but we can still maneuver this problem. Okay, what is this? I'm gonna get to the free response section. So this part where you see these B's, this is the calculator section. There's 15 questions. Most of them, however, don't even require you to use the calculator. Okay, so here's the free response. There are 6 free response questions. The first two, number 1 and 2, are calculator questions you can use the calculator on. Typically, you will need the calculator for them. We're not going to really need the calculator for this. All right, so in doing this problem, I'm going to kind of foreshadow something that we're going to learn next week about, position, velocity, and acceleration. I think we talked about this in the advanced pre-calc classes last year. So you may be familiar, but I don't know. But anyway, so here's this table, right? This table actually represents velocity. The units of V are miles per hour, and the units of T are hours. They want me to use the data. Actually, let me read the problem. So Ruth rode a bicycle on a straight trail. She recorded her velocity in miles per hour for selected values of T over the interval 0 to 2.4, as shown in the table. And so that's all they tell me. Well, they do tell me the velocity is going to be greater than 0. All right, so use the data in the table to approximate Ruth's acceleration. So acceleration is the derivative of velocity. That's something we get into in more detail next week. But I'm going to tell you right now, acceleration is the derivative of velocity. Velocity is the derivative of position. Acceleration is the derivative of velocity. So to find the acceleration at t equals 1.4, I need to find r prime of 1.4. And now this is technically an approximation, correct? So technically when I'm doing free response, I should write these approximation symbols. I should. If I wrote equal signs, I'm not gonna lose any points. So you can write equal signs, you're not gonna lose any points. But technically, this is an approximation, and so you should use the approximation symbols. All right. So 1.4 is between what numbers up there? 1.2 and 1.6, correct? And so we're just gonna do our little slope form with these particular numbers. So 6.16.3 minus 17.2 over 1.6 minus 1.2. So the top is negative
Bless you.
0.9. The bottom is positive 0.4. And so since this is a calculated question, I guess I can get the negative 0.9 divided by 0.4. So negative 2.25. What is this? That's not what I was doing, was it? What was it? 2.25? All right. That would be the answer, correct? Now, this problem, okay, I was about to say, it didn't ask me to find units of measurement. It actually did. It says indicate units of measurement. And that's why it's very important to read this. And it says show the computation that led to your answers. We show that, indicate units of measurement. I want to get all the points I can get, particularly on a problem I understand. This problem is going to be a problem you're going to understand. There can be others, especially some of the stuff they did last year, you might struggle with. But you want to get all the points you can on this guy. So, what are the units of measure?
Hours and miles miles per hour.
Miles per hour, right? When I take a derivative, I get the units of the function per the independent variable. So miles per hour per hour. Right. You can also write miles per hour squared. All right, any question with that? Your first little free response. And what is this? This is 1A. I want to kind of give you, even though we're not deeply going into the free response here, I want to kind of let you see how this is scored. Like what they want to see to get all the points on this guy. The more familiar you are with how the free response is scored, the better your score is gonna be. So on this one, it was only 2 points. So I get 1 point for the approximation, but when they're grading this approximation, like you don't have to write this, but they need to see this jump, and then of course another point for the units. Now you may say, okay, that's only 2 points. When all this stuff is added, every point matters, particularly on stuff you know how to do. So you make sure you have everything that they're asking for. All right, any questions with that? Okay, I'm going to stop there. There is going to be an assignment for today. Today's assignment, I think it's called derivatives 11 or 12. Derivatives 12, I think is what it's called.